Welcome everyone to reducing instrumentation verification by up to 80%. Welcome to our webinar. Just before we get started, if you would like to go to menti.com and enter that number on your screen, or you can also scan it with your phone. You'll need that later in a few minutes. But just before we get into the content of today's webinar, we're going to be just refreshing you about the GoToWebinar interface. So on the right-hand side, you'll see the presentation and the files that are in the handout for today. You'll also be able to see the screen. You can reshape that. But more importantly, throughout the webinar, you'll need to enter your questions. You can see over there into this box, and we'll answer them at the end. So make sure that you do put your questions in there, and we as a team will get to them at the end. Today, I'm just going to briefly introduce the presenters that will be talking to you about verification with Heartbeat technology. And first of all, I will introduce Luke, and he will talk a bit about himself. So Luke.
Thanks, Taylor. Hey everybody, hope you're all well. My name's Luke. I am the industry manager for water and wastewater here at Endress+Hauser. I also wear a second hat as the product manager for liquid analytics, and we're going to be talking about that towards the end of the webinar. Taylor, I'll pass back to you.
I'm Taylor McCurtich. I'm the industry manager for mining, oil and gas. So I've been with Endress+Hauser for about 3 years now, coming from an operational process engineering background. And now I'm going to be handing over to Gustavo.
All right, so hello everyone. My name is Gustavo Queiroz, or simply Gus, and I'm the industry manager responsible for the food and beverage market here in Australia. And I've been working with Endress+Hauser for nearly 10 years right now, most of this time in Brazil before I moved to Australia. So now I can hand it back over to Taylor, who will give us an introduction about today's webinar.
Excellent. Thanks very much, Gustavo. So the agenda for today, we're going to be talking what instrumentation verification is. We're going to be speaking around why it's important for your process and the benefits that come with verification. Then we're going to be talking about heartbeat verification and how it can be used to improve your process. We'll go through some different examples around flow, level, and liquid analysis portfolio. And then we'll be doing also some live demonstrations with those devices and those portfolios. Then Luke will touch on some of the cost savings around heartbeat verification. And then finally, of course, we'll answer any questions that you might have throughout the webinar. First of all, I'm going to be kicking off talking around some verification concepts. So there's 3 terms that we hear floating around in the industry around instrumentation and making sure that it's reliable. First of all, calibration. So calibration is all around establishing that relationship between the real measured value and the signal that is produced by the device. While validation is around comparing the device to a standard measurement. So in food and beverage, pharmaceutical, and life sciences processes, it's the process that's normally validated. While verification, and that's the focus of today's webinar, we'll be speaking about proving confidence and performance in accordance with specification. So this is around analysis of secondary variables. So you might have been hearing these terms being interchanged throughout the industry, and we find that from experience as well, calibration or validation is done while only verification is required. So hopefully today's webinar will clear a few things up. So I spoke about calibration and verification, but what is the difference between the two? So verification is around the comparison of the secondary variables that are correlated. So for a flow meter, they might be coil resistance, reference voltage, etc. While calibration is a comparison of the primary dimensions, so the quantitative information. So for a flow meter, that means flow rate, density, or volume. And all the verification is traceable according to ISO 9001. And Gustavo will speak a bit about that later. But first of all, Menti. So make sure that you scan the QR code on the left side of your screen over here, or you can go to menti.com, type in 235579, and I'm asking, why do you need to complete instrumentation verification in your process in your plant? So the option is you have to do it because you have to comply to regulations, or maybe it's part of your maintenance procedures, or maybe you see the value in it and you want to extend your calibration cycles. And finally, maybe it's all those three reasons. All right, so we're seeing the results start pouring in now. Of course, if you didn't get time to scan that QR code with your phone, you can always go to menti.com and use that code 23, 55, 70, and 9. All right, we're looking to see quite a few results pouring in now. Looks like the majority of you believe that you need to complete instrumentation verification because of all three reasons: regulations, maintenance, and calibration cycle. So that's quite interesting information. I'll just give you a couple more seconds now to have an opportunity to vote for the Menti. All right, that's it. So all of the above reasons was the main one from 60% of you guys. So why is verification important then? Well, again, regulations. So a number of standards have specified that the equipment needs to be verified prior to the first usage and then again verified again at regular intervals. Now, the length of these intervals is dependent on the quality system used and the criticality of the measuring point, and that needs to be determined on site. But the measurement traceability documentation that is worldwide recognized is ISO 9001, and that's talking about verification equals compliance. Again, why is verification important? So it's around maximizing that the confidence in functional performance of the devices. So whether they're in safety relevant measuring points or whether they're in critical process measuring points on site, you want to have confidence that your device is verified and working correctly. Of course, as we spoke about before, in ISO 9001, we're talking about the requirements for the test protocols. And of course, a great benefit of verification is that it can be completed in situ, so enabling the extension of those recalibration cycles without interrupting the process. And of course, verification can reduce your risk of failure, and that means you can reduce your unplanned maintenance costs and save you time and money as well. So now I'm going to be handing over to Gus, and he's going to be speaking about what heartbeat technology is. Thanks, Gus.
Thanks, Taylor. All right, hello everyone again from my side. Before we dive into the heartbeat verification, I want to give you an introduction, like an overview about what is heartbeat technology, okay? So, oops, yeah, there you go. So basically heartbeat technology is an advanced diagnostic concepts we have embedded into our instrumentation portfolio. And it's based on three main pillars. We have the heartbeat diagnostics as the first column. We have the heartbeat verification, the column in the middle, which is really the focus of our webinar today. And we also have the heartbeat monitoring. The heartbeat diagnostics mainly focus on the standardization of the failure and warning messages according to NAMUR NE 107. So basically, we're trying to make it simple for you to know what's happening with your device and to make the actions that you need to do to correct them so you can really save time and improve your maintenance, okay? The heartbeat verification involves the complete assessment of your device without the need to take your device out of your process. So Taylor gave us an introduction about verification, so we're going to explore this a little bit more in details in a couple of minutes. And the third pillar on heartbeat technology is what we call monitoring. So basically, on the monitoring aspect, we are evaluating several key performance indicators from a performance perspective, from an operational perspective, to predict, for example, if you have any kind of operational problems such as buildup, corrosion, and etc. And these are all the three pillars that we use to turn the heartbeat technology as a really powerful tool for your maintenance and your operational strategy, okay? As I previously mentioned, we have the heartbeat technology across our portfolio. So today we already have this with our flow portfolio. We also have this with our level portfolio and the analytical instrumentation, liquid analysis in general. We are bringing this concept to our pressure devices, but Taylor will talk about this a little bit later on, okay? And how to run a verification? Well, we want to bring to our customers a very easy way, a very easy concept and approach, so anyone can run a verification regardless of the type of technology they use. So you can run a verification either from your device display. I'm going to show you how to do this in a couple of minutes, but you can also run verification using your SmartBlue app from your smartphone, or even using a web server. So these three different approaches we're going to cover in the webinar today. But if you have a handheld device, such as a tablet, such as the Field Expert with Device Care or Field Care, you can also run a verification using these devices. And if you need to work in a very more, let's say, elaborated way, you can also create an automatic routine on your PLC or your DCS to run a verification automatically. For example, after 3 months or 6 months, you can run the verification and it can automatically export the reports straight away. So it's a really powerful tool, and there are several different ways for us to approach it. So let's go straight to the point and talk a little bit more about heartbeat verification for flow instruments. So basically what we have, when you run a verification, you want to assess, you want to evaluate what is the condition of all the components that constitutes your flow device, okay? What we have on the new generation of flow meters from Endress+Hauser is several measuring systems, several measuring components embedded into the electronics and on the sensors. And whenever you run a verification, it will measure all the current values of all these components. You can see from a sensor and from an electronic perspective. It will compare these values to how the instrument was when it left the factory. So when we produce the instrument, we record all these values, we store them at the device, and we compare. Whenever you run a verification, we compare all these values, so you can have an idea, for example, what are the components that are stressing more during your process, what are the components that are wearing out during the operation. So when you run a verification, you get a report, and we'll show you the health of each of these components, and we're going to explore a little bit more about this in a couple of minutes as well. Okay. One of the main differentiators we have with heartbeat technology is, one, you don't need any external tool to run the verification report. You can just go to your display, you can just go using the web server or using your control system and start the verification straight away without the need of any external resource. But it also, the other key differentiator is the compliance with ISO 9001. So we can ensure all the traceability of these reports. So whenever you need to supply any documentation to see, to test, to certify that you really test your devices, the heartbeat report follows all the ISO 9001 compliance requirements, okay? And we also have a third-party compliance, which was attested by TÜV, which is a German institute, saying that the heartbeat verification is really reliable, and you can rely on the heartbeat report. And we have a very interesting coverage aspect of the device. So with the heartbeat verification, we can ensure that more than 95% of all your instrumentation is tested and really evaluated. Okay, just we have here one. Here's just one of the examples we have for the water and wastewater industry. So whenever, especially in applications where you have very high diameters flow meters and you need to verify them, it's very hard for you to go on site or even to take them out to run a calibration. With a heartbeat verification resource, you can run it straight away in shorter periods of time, and all the certification and all the reports are in compliance with the ISO 9001. So it's a really powerful resource to have. And here is just a comparison between on how the heartbeat verifications that run today. You'll see in a couple of seconds that the heartbeat verification for a flow device takes less than 1 minute. It's really, really easy for you to do. If you compare with the previous technology that was available, which was with the field check, a very basic flow meter verification used to take 45 minutes. So it's a very interesting resource for you to really optimize your verification and maintenance plan. Okay, I'm going to show you how to run a verification from your device right now. So I'm just going to step aside. Okay, so here I have a Flow ProMag 300 in front of me. Okay, so to run a verification is pretty simple. All I need to do is go into the setup, scroll down to Diagnostics. Yeah, here you go. Under Diagnostics, you need to find the heartbeat option. So you can just scroll down until you find the heartbeat. Yeah, here it is. Heartbeat, enter. And here we have a general overview about the heartbeat options. We're gonna go through perform verification. Let me press enter. Yeah, we have a couple of information we need to input into our device before we run the verification, such as the year, the month, and the day. I already pre-set up this, but it's very simple. And once you scroll down to start verification and you change this value from cancel to start, the verification will start straight away. And you can see the progress below. You can see here 527, 38%. So the verification is happening right now. And now it's completed. And we can now see what is the overall result just under this one. So it's done. If I just scroll down, you can see that this device in specific failed. Okay. If you want to go deeper to try to understand what really happened with this device, you can go back one step and go to verification results. Let me just press enter here. Awesome. So you can have the date and the time of the last verification, and you can see what are the overall result again, and what are the components results. So the sensor pass, the sensor electronics pass, and the I/O module for this specific case failed. Okay, so this is how you run a verification. This device has a web server integrated, so you can easily export the report, as you can see here. Oh, moving back to the camera. Can we just go back? Okay, so this is the verification report you can export from your device using the web server or using any other different tool. So you can have a detailed information about all the components the device was tested and which one failed. And from this report, you can send to our service team to initiate, for example, a remote support to see if we can replace or to see if we can work on the maintenance remotely, or if you need to do any kind of replacement of any components and so on. So now I'm going to hand it back to Taylor, who will go for the heartbeat verification for level and pressure devices.
Thanks very much, Gus. So yeah, I'm going to be talking about heartbeat verification for level and pressure instrumentation. So again, what we can do on flow devices, we can also do on level and pressure portfolio. But what devices in our portfolio have heartbeat verification available? Well, we have quite a large range now. So our Micropilot family, our Level Flex family, which are free space and guided wave radar. We have our density gauges, so the FMG50, and also the FTL51B, which I'll do a demonstration of very soon. And our pressure family also will be coming with heartbeat verification very shortly at the beginning of next year. So again, this might look a bit similar to you. This is a level verification report. So it can be generated with any wizards that are used for the level or pressure portfolio family. You can see on the right-hand side here, these are the different modules, sensors, and components as an example that can be checked with heartbeat verification. And a lot of the similarities between the flow portfolio and the level portfolio verification report you'll be able to see here. The great thing is you can also perform a remote heartbeat verification even with devices with 4 to 20 milliamp I/O. So you can use Bluetooth and the Smart Blue app, which we'll do very shortly, to verify your device as well. So it means you don't have to climb up those ladders for those tall tanks, and it makes it much easier and safer while you're on site. A use case for this in the oil and gas industry is that in conjunction with proof testing, you can also verify your devices in an overfill prevention system, for example. The great benefit to that is to ensure that your safety and your process critical instrumentation are verified. So not only is the primary purpose of the device working, but also you're getting some more insights around the health of the instrument. So you can, one, improve compliance in accordance to your safety health management systems on site, and two, improve your part availability and reduce your costs as well. And we can use heartbeat verification to assist in those demands because it provides a traceable report according to ISO 9001, and it's very fast and easy to do. In fact, it's so fast and easy to do, I'll do it right now. So make sure you do pay attention because it's going to take a very short period of time to do so. Now I just need to bring my device over here. So that's great. I've got an FTL51B in this bucket here. So I'm going to be placing it in the bucket, and that is going to suppress the vibronic forks here, which should give us a fail on the heartbeat verification. And now I just need to use my smartphone with the Smart Blue app installed. All right, cool. All right, so all I have to do now is click on the Smart Blue app. And once I've done that, then I'll be able to connect to the instrument. Okay, so once I've opened my Smart Blue app, yeah, awesome, then I can find it here. Now, once I've connected to the device, it'll be quite easy for me to do the heartbeat verification. So I just need to type in the password and the user ID. Okay, so you should be able to soon see that I'm logging into the device. It uses Bluetooth, of course, and it has smart security as well. So that when I log in, and it should be coming up very shortly, it can tell me the previous events, and also I can need to change my password as well. So I just go into this menu here, click heartbeat verification, and while it's loading, then I just need to go through the menus, click the heartbeat verification, press OK, and now it's going to be doing it. So now I just press next. And now this is going through the different components of the part. So you can see that the frequency test has failed. As I mentioned before, it's in the bucket. And now I'm going to be generating a PDF report of the heartbeat verification. So you'll see it takes very quick. It's only about another 5 seconds before the report is generated. But now it should be showing up. Okay, cool. So you can see through here the results of the heartbeat verification report. The components that have failed are located in here. And it's really as easy as that. So much faster and easier than traditional devices for the field check as well. Okay. So now I'm going to be handing it over to Luke, and he's going to be speaking about the use case in liquid analysis.
Thanks, Taylor. Hopefully everybody can hear me. So Gustavo has talked about verification and flow, which is probably the most common type of verification that we normally do, and I'm sure our customers do. Then Taylor's also spoken about verification in levels. So just to wrap things up, I'm going to talk to you about heartbeat verification for liquid analysis. So if you just want to go to the next slide. So on this slide, it really shows you all of the parameters that we have in our portfolio. There's a few that we don't show there, some gas type analyzers. And what this shows is where we have heartbeat verification available and where we're planning to do it. So you'll see in the top half, all of the standard types of probes, pH, ORP, ion selective, photometers, conductivity, DO. And then in the bottom section, we have all of our wet chemistry type analyzers. So phosphate, TP, silica, hardness. At the moment, we have heartbeat verification available for all of the probes you see above, and then also for our samplers. So just as Gus and Taylor had explained before, what kind of parameters are we looking at when we generate heartbeat verification for liquid analysis? So on the next slide, you'll just see a brief snippet of some of those parameters. The portfolio being so large, there are hundreds and hundreds of parameters you can pull from these probes to generate the verification report, and then overall to generate the health status of your probes. I've just shown you a brief snippet of it here. Analytical probes are subject to all different types of conditions, whether it's high temperatures, low temperatures, high pH values, low pH values. They also have electrolyte consumption, pH glasses get broken. We also have CIP processes in food and beverage, we record the vast majority of these events in the probes, and then we transfer that to the transmitter. And then what we do at the end of that is that we combine all of those parameters together in some algorithms that we run, and we give you an overall health status of the probes. So on the next slide, you'll see exactly how we combine all of that data to make it really easy and manageable for you as an end user or as an operator to see the health status of our probes. So the way we do it, we just use smiley faces. So we take all of those monitored sensor values, like high pH events, low pH events, temperatures, glass impedance, calibration results, and we combine those together to give you the sensor health. It's really, really simple to understand. The smiley face means you're good to go, nothing's wrong with your probe, carry on as you are. The straight face here in the middle is you may need to take some attention on your probe, possibly perform a cleaning or a calibration, and the unhappy face is you're in trouble at this point. Do your calibration, do your maintenance really quickly, or your probe is likely to fail. So this is how we combine all those values together. Now, exactly what is the value of the verification report for liquid analysis? We know it's predominantly for compliance, for flow, for level. You can look at some diagnostic values there, but what does it all mean for liquid analysis? So I'll show you a typical use case on the next slide. So if you want to flick to that. So let's look at one of probably the most extreme events for any pH or analytical probe to go through, and that's cleaning in place or CIP type processes. These are super common across the food and beverage industry and also the pharmaceutical industry, and it puts some massive demands on the probes. So the CIP process causes a big thermal shift, so you're going from 25, 30 degrees all the way up to 80, sometimes up to 120 degrees during steam cleaning. So it's a big, big thermal change there, and it's going to cause some health effects in probes. In addition to that, there's some mechanical stress as well. We're putting some pretty high flow rates through here. How is that going to influence our probes, in particular pH and conductivity? So what we need to do and what we need to help you with your maintenance procedures is documenting the health status of these probes. So how can we take all of that information I showed you on the previous slide and put it into really simple to understand report to give you specific values or KPIs that you're interested in? For example, when was my last calibration event? When was the last time my probe failed? How long has my probe been in failure? Were there any thermal stress events? We can document all of that in 3 or 4 pages. So that's what we do with heartbeat verification. So in a couple of clicks, we give you a verification report that gives you a snapshot of the probe health status at that particular point in time. Now you can imagine if you run a number of verification reports over an extended period of time, say 2, 3, 4 months, you can take all of those KPIs that I spoke about before, you can plot them, and then you can really start to understand your maintenance a lot better than you did before. And then you can maybe improve your maintenance procedure. Let's say, for example, you can extend your calibration intervals, or you don't have to retract your probe as much for cleaning. What heartbeat verification diagnostics does is it gives you an indication of how you can improve your maintenance procedure. Now, we're not going to talk about that in this webinar, but in probably 2 or 3 weeks' time, we're going to have a webinar dedicated to improving maintenance schedules with heartbeat verification and diagnostics. So we'll give you real examples of exactly how you can do that in our next webinar. So just how Gustavo and Taylor did demonstrations for heartbeat verification. Gustavo did it with the local display, Taylor with Bluetooth. I'm going to show you how to do it on the web server. So here's a real example. This is one of our transmitters that we've connected remotely. This is happening right now in our process. All we have to do, type in the IP address, your username and password. Now we're remotely into the transmitter. So anything that you could see locally, you can now see via the web server. So the first thing you'll see is that heartbeat status. All our probes are pretty healthy here, nice smiley faces. Let's go and have a look at the pH probe and see the health status. We're looking 83%, so we've done a calibration there, so the health status has dropped slightly. Now I'm going to show you exactly how you can document all of those values in a couple of clicks. So we'll go to Diagnostics, then we'll go to System Test, then we're going to scroll to Heartbeat. So remember, this is all remotely. Click on Performing Verification, then you click OK. Now we can even export that verification data remotely. So you don't have to leave your control room, you don't have to leave your office, you can do all of this remotely. So we're going to go export to SD card, it says it's successful. Then we'll click on additional functions, go over to heartbeat. Click on that heartbeat. So this will be the latest verification report that you've run. It's going to save it into your downloads or wherever your default drive is. Let's double click on that verification report and see exactly what we've got. So we've got a title page, just as we did with the other devices. That gives you all of the transmitter information. Then we're going to look at all of the transmitter diagnostics, just as we did with the flow meter. And then we can also see the probe diagnostics. So on the next slide, I'm just going to give you an example of what that verification report looks like. So that's the report that we've just run before. So on the left-hand side, I know it's slightly hidden. There's that title page. So what the device is, where it's installed, what's the tag name, the serial number, the firmware, all of that standard information that you can use for your documentation. Then on the second page, it does tests on all of the transmitter functions. So similar to what we did in the flow meter, we're looking at the IOs, we're looking at the power supplies, the operating time, whether it's ever been in failure. And then on every page after that, we look at the sensor diagnostics or the sensor KPIs. So for this example, we had conductivity, DO, and pH. You can get 8, 9, 10 pages here in your verification report. So we look at all of the sensor functions. So whether it's been in failure, when was the last calibration, if we've seen any major thermal stress events, you can tailor this to whatever your probes are and use that to really optimize your maintenance procedure, which we will be going through in a few weeks' time. So that's a really brief snapshot of liquid analysis. We will provide all of you with those verification reports that we've run in this session. So you'll receive a follow-up email probably at some point tomorrow, and you'll have the option to download those verification reports and really dig into exactly what we've done and where you could maybe use it in your process. So to wrap things up, what I'm going to do now is quantify how heartbeat verification can save you costs and time as well. So what we did a couple of weeks ago, and some of you may have seen this advertised on LinkedIn or even to your own personal emails, is that we developed a return on investment calculator. So for you, what you really want to understand is, where is this going to save me money? So what our tool does is show you exactly how we can do that. So we've taken into account travel time, flights, accommodation, service time, what it would cost for a normal verification, what it would cost you typically for a verification, and we've built this all into the tool. So, and we'll give you a link for this at the end of the presentation as well. So in this particular scenario, let's imagine that we've got 10 flow meters that you need to verify every year, so every 12 months. In your network, you've also got 5 flow meters, that may be a little bit more important than those other 10 that you actually need to verify every 6 months. And this particular site is 800K from a capital city. In this example, we've got Brisbane here on the right and somewhere out back on the left. I'm not sure which town. So exactly how can we save, or how much money can we save with heartbeat verification rather than your standard verification procedure, which Gustavo discussed before? So that would normally be done by a service tech or by yourself. So we'll give you a demo of this heartbeat ROI calculator. So here it is here. So remember, we had 10 flow meters that we're going to verify once a year. So all you do, you enter 10 into that top section there. So we'll just scroll down to 10. Then we had 5 flow meters that we're going to verify every 6 months. So put that number in there, and we're 800K from any capital city. And the 2 numbers that you'll get out of the end there is what your cost savings are. So what's your cost savings against a normal external verification? And then the really important number, what's your payback period? So if all these devices had heartbeat, your payback period is just over a year, and you're saving just over $5,000. What this tool also does is gives you all the benefits that myself, Tony, and Gustavo have discussed, all the features for different products, what's available, what we're planning in the next few months as well. And also on the final tab as well, just to give you an idea of how exactly we've calculated, we give you some assumptions here, some of our assumptions for this return on investment. So that's it for me. That was liquid analysis. That's how much money you can save now we've got roughly 10 minutes for questions, and I think we'll bring back in Taylor and Gustavo. So thanks everybody for listening. Now let's get on to the questions now.
Thanks very much, Luke. Gustavo is going to join me as well. So again, a reminder to make sure that you type in your questions on that right-hand side panel, and we'll get to them now. So Luke, has any questions popped through?
Yeah, we do, Taylor. We've got a question from Greg here. He's asking, can you perform the verification while the sensor is in operation or online?
Gustavo, do you want to?
Yes, sure. So the heartbeat verification you can be run in any operating device. So you can run the verification while the instruments are running. This applies for flow, level, liquid analysis, and any other instrument from our offering. So feel free to run the verification straight away. You don't need to do anything else. Just press the buttons and go through.
I guess we can probably show the example of the FTL51B. So when I did that on the SmartBlue app, that was when the device was operating as well. So it's quite easy just to do that, and the signal is still being sent back, as it would be without the heartbeat verification process. I see a lot more questions coming through, Luke. What's the next one?
Yeah, we have got a question here about the web server. So hello, can you show how to connect the sensor data to the web browser? After this seminar, probably at some point tomorrow, you will receive a follow-up email. And within that, we're hoping to provide a link that demonstrates how we did those verifications for each of those devices. If we don't send it tomorrow, then within about a week, we will give you another link to have a look at those verifications. So we gave examples for Bluetooth, another one locally, and another one via web server. You'll have the option to watch each of those again. Feel free to contact us directly and we can give you a live demonstration too. Got another question, Taylor, from Romeo. Is Bluetooth available for flow meter verification? Taylor, I could probably answer that. Next year, we are going to be releasing a couple of flow meters that do have Bluetooth capability and do have heartbeat verification capability with those flow meters. So stay tuned. Probably in the first half next year, some of those devices you'll start to see, so you can trigger verification via Bluetooth. Another question here. Can you use it to produce a commissioning report? And that's a question from Dave. That's a good question as well. So look, we've seen the benefits for the end users here, for their compliance type procedures or their maintenance procedures. But another question we often get asked is maybe by companies who are constructing a particular plant, is where is the benefit for heartbeat verification for me? And what we found and what some of our customers have liked is that we say that you can use this heartbeat verification within your reporting to the customer or to the end user. So when you deliver all of your commissioning documentation and they want to prove that these devices are installed correctly and working as you should, you can just trigger heartbeat verifications for all of your devices on site and include that in your commissioning report to the customer. So it's valuable not only for the people constructing the plant, but also for the end users at the end as well. Got a question from Jose. It's a security question. It's a good question, Jose. So is there a risk of any security issues using all types of mediums, for example, Bluetooth and web server and wireless LAN access?
So in the Bluetooth, the SmartBlue app, you would have seen that I had to enter in my username and password. So it didn't show on the video recording because with the mirroring of the iPhone, it doesn't show up passwords. But I was typing in a password there, and that is something that one you can change on site if you wish. The default is a serial number, so you actually have to be on site. You can't remotely hack in from another way for Bluetooth. Bluetooth's quite secure. In terms of the web server and other information around that as well, Luke, did you have any information around the security of the web server?
We can dig into it some more. It's a really good question. Everybody's sensitive about security, and so they should be. I will provide some examples of the web server's security for you. and you can look at that. I'll send it probably in the next day or so. We've got a really good question from Ed as well. So Ed's asking, why is there no statement in the certificate about the percentage accuracy? So, and the field check, which is with our previous type of verification for flow meters, has a statement of the percentage deviation from the original factory data. Ed, that's possible with heartbeat verification. It is an advanced type of verification procedure. You will need to use field care, as far as I know. Taylor, you might be able to, or Gus, you might be able to comment on it. So you can still run your heartbeat verifications using field care. You'll get an advanced verification report with that. There's still an advantage with heartbeat verification because you don't have to connect to the device as you did before. You can just use a web server on your computer instead. So there's still lots of time savings. And you still can get that quantitative deviation, Ed, from your original values as well. So that's still possible. Another question here. I'll hand this over to you guys. So Gustavo, this one's for you. Can you upgrade your existing instruments to heartbeat?
Yes, pretty easy. All you need to do is contact your sales guy, the responsible for Endress+Hauser, and ask him that you have an existing device. You need to upgrade it to heartbeat. All you need to do is send the serial number, and we'll generate a code to upgrade your current device to the heartbeat version.
Cool. I've got another question here. So someone's mentioned using these diagnostics, or what we call diagnostics, or one of those 3 pillars to improve your maintenance procedures. Are there any examples of that, or are you able to talk about that?
Yes, so this is around how you can use verification to extend your calibration. So it depends on what type of systems you have on site, and also what standards you're following and your maintenance strategy as well. But you can utilize the information that is gained from the heartbeat verification in order to determine whether or not you need to calibrate at different intervals.
Yeah, I think to add to that as well, in a few weeks' time, we will be running an online seminar specifically for heartbeat diagnostics, and we'll give you real examples of how you can improve your maintenance procedures using this diagnostics, which is the second pillar of heartbeat verification. I've got a question regarding the presentations. Can you look at this presentation via YouTube later because they can't hear it? Taylor, I'll take that. Yeah, we're gonna send an email tomorrow, and you'll have a link to watch the webinar live as well. Probably time for one more question. So this one's in regards to the differences between calibration and verification. So the question is, would you use verification over calibration? If not, why?
Discuss the differences between calibration and verification. So calibration is around making sure that primary variable, the quantitative value from, for example, in a flow meter, it's around the flow rate or density or whatever primary variable you are measuring, while calibration is around information of the secondary variables. So that is around the health of the electronics and the health of the instrument itself. So as you can see, there are 2 different things. So calibration is really, I guess, the information from verification is able to extend that calibration interval, but the 2 are quite different topics. So it just depends on what you're trying to achieve there. Yes.
Just a couple of comments. The verification does not have any metrological aspect. So when you run a verification, you're assessing and you're evaluating the health and the condition of your device. You're not comparing like the measurement values to another standard. So you can use this as a tool to justify, for example, the extension between the calibrations, but you cannot use this as a tool to say, okay, my equipment is measuring well, because you're not comparing your device with the primary standard. So there's a slightly difference. You can use, as I said, as a resource to optimize and reduce your costs. But the idea is not to replace the verification, it's not to replace the calibration by a verification. It also depends on the criticality of your device and internal compliances. So it's mainly up to the customer to decide if the verification is enough for them, or if you really need a metrological aspect to that measuring point.
Cool. Let's do a couple more. Just to add to that, we've got a question here from Jack, and it's after the verification, based on the result, is it possible to do a remote calibration?
Oh, it's not possible to run a remote calibration. To run a calibration, you need to compare it with a standard. So you need to take your device out of your process or bring let's say a remote rig to your site so you can run a verification and compare it to a standard. You can only run the verification and get the results, but you're not from a metrological perspective, you cannot adjust or calibrate your device just based on a heartbeat verification or any other kind of electronic verifications. Okay.
Yeah, I think my answer to that would be I wish we could do remote calibrations. Right, final question from Ed to wrap things up. So I understood that heartbeat diagnostics is the basic function. Can we identify in the field whether the flow meter is fully equipped with verification and monitoring aspects or tools? So how do we know if the device has heartbeat or if it doesn't?
In the serial number, you can enter that into the common equipment record, which you can get information around whether the device has heartbeat. Of course, you can have a look also at the nameplate. It will have an extended order code, and that you can type in our website, and then it will be able to give the configuration of that device, and you can see as one of the options has heartbeat technology, and that if it does have heartbeat technology, then you can use it to verify the device. All right, thanks very much, Luke, for those questions. I think we'll wrap it up there. If we didn't get to your questions during the webinar, we'll get back to you individually afterwards. And of course, we'll send out a follow-up email as well with the presentation, the recording, and some more information around what those reports of verification actually look like, so you can have a look at some of the information in there. So thank you everyone for joining, and we'll see you next time.
Cool. Cheers, Taylor. Cheers, Gus. Thanks, everyone.